What is up, my Treadwell Eagles? I hope today finds you well. This is the first video I've posted since school was canceled due to COVID-19. And there are plenty more videos to come as time progresses. We're going to continue where we left off and move into standard 7.ESS 3.1, which states graphically represent the composition of the atmosphere as a mixture of gases and discuss the potential for atmospheric change. So in this video, we're going to talk about the atmosphere, its layers, and some of the factors that contribute to why the atmosphere is the way it is. All right, so let's get started. First of all, what is the atmosphere? All right, the atmosphere is a mixture of gases that surrounds the planet. We can call these mixtures of gases air. All right, and then the air that we have is composed, at least on Earth, is composed of 78% nitrogen, 21% oxygen, and then 1% other gases. All right. There are also particles in the atmosphere like dust, all right, dust and volcanic ash and other factors. Now, the water vapor in the atmosphere, it's part of the other gases, is going to connect to this dust, and that's what's going to cause our clouds to be formed. All right, so those are important particles in the atmosphere. Another other gas is carbon dioxide, which will be important when we talk about atmospheric change, fossil fuels, things like that. Why do we need the atmosphere? Why is it important for Earth? Well, there's two main reasons that it's important. Number one, it protects us from the harmful layers of the sun, harmful rays of the sun. The ozone layer is what protects us. So what happens is the sun is beaming down on the Earth, and there are certain rays like ultraviolet rays that are pretty harmful for us as humans. But the ozone layer is actually going to block some of those layers from entering the Earth, or some of those rays from entering the Earth, which is going to keep us safe, protect us from those harmful rays. It also maintains the correct temperature range. This is called the greenhouse effect. So when the rays get into the Earth's surface, all right, they are trapped by our atmosphere, kind of like a greenhouse traps heat. All right, and this allows us to live at our correct temperature range. If we didn't have the atmosphere, the Earth would be a block of ice. It would be super cold. All right, so this allows life to flourish and exist because we have that atmosphere. Now, let's talk about air pressure, but before we do, I want to talk a little bit about gravity. The reason we even have an atmosphere is because of gravity. Gravity is pulling those molecules in towards the Earth and allowing them to stay close to the Earth. If we didn't have gravity, our atmosphere would just dissipate into space. It wouldn't be able to be held down. Air pressure is the measure of the force with which air molecules push on an area or a surface. All right, so what that means is, I don't know if you've ever hiked in the mountains, but basically the higher you go up, the harder it is going to be for you to breathe. All right, so as you hike up a mountain, the air pressure is going to get lower, and people will also say the air gets thinner. All right, which means it's going to be harder for oxygen to be consumed by us. And we know from our study on aerobic respiration that with oxygen, we create the maximal amount of ATP or energy that our body needs. But if we're not getting that oxygen, right, we're going to have to do more anaerobic respiration, which means we're less efficient. We're going to be more tired because we don't have as much energy. So that's air pressure. It's kind of the pressure that air puts on the Earth and on us. So let's move into the layers of the atmosphere. We've got 5 layers. We've got the troposphere, that's where we live, the stratosphere, the mesosphere, the thermosphere, and the exosphere. Let's talk through these prefixes and what they mean. Tropo means turning or change. And what that means is the gases in the layer that we're living are mixing around, they're turning and changing, and they're all mixed in together. Strato means layers. So once you get into the stratosphere, that's where the ozone layer is. All right, there are layers of gases on top of each other. That's why we get the ozone layers, because it's a layer of ozone. And there's also other layers of other gases. Meso just means middle, and the mesosphere is the middle layer of the atmosphere. The thermosphere, thermo means heat, and like heat indicates, this is the hottest layer. Exo means outside or external, so the exosphere is the outside layer. All right, and it turns into space. So there's really no clear distinction between the exosphere and space. The atmosphere fades into space. Let's talk about the temperature as we move through the layers. Temperature actually defines each layer. So as you move to each layer, we notice that the temperature is changing. So in the troposphere, we have a decreasing temperature. All right, and then we hit the stratosphere, and our temperature starts to increase again. All right, mesosphere decrease, thermosphere increase until we get really, really hot temperatures. All right, so as each layer progresses, the temperature change is going to shift. All right, remember thermo means heat, and so that's going to be our hottest layer in the atmosphere. Air pressure, we talked about this a little bit earlier, but it has an inverse relationship with altitude. All right, so as we increase in altitude, as we go up in the atmosphere, the air pressure is actually going to decrease. All right, so as we move up a mountain, we're going to have less air pressure. It's going to be harder to breathe, and as we move up more into space, our air pressure is going to decrease even more. Those are the layers of the atmosphere. Troposphere is where we live again. That's also where clouds exist, most clouds. And hot air balloons fly, airplanes fly in the troposphere, and some a little in the stratosphere. And then our high-powered planes, our jets and such, will fly in the stratosphere. Also in the stratosphere, if you see, we have our ozone layer. It's a very important layer that we'll come back to in later videos. The thermosphere and the mesosphere is where our meteors start to catch on fire and break down, which is why a lot of them don't end up hitting the Earth's surface. Then we got satellites and rockets in our thermosphere and exosphere. So yeah, that's our atmosphere. It's very useful. In the description below, I have a quiz for you. All right, so make sure you go to that Google form and you take that quiz so I can just see how you're gleaning this information. Again, I miss you guys and wish I could be in person, but this coronavirus is some serious stuff. So hope you're doing well and look forward to seeing you in the next video.